Hi, welcome to SP MPC classes. Today we are going to see is matter around us part 3. In this video we are going to cover topics separating the component of mixtures: evaporation, centrifugation, decantation, sublimation, chromatography, distillation and fractional distillation. These topics we are going to cover. The component of heterogeneous mixture can be separated by simple methods like hand picking, sieving, filtration. Sometimes special techniques are used to separate the components of mixtures. So now we are going to learn about the special techniques to separate these components, especially heterogeneous mixtures. Let us start. Evaporation. You know what is meant by evaporation? Evaporation means conversion of liquid directly to the gaseous state. This method is used for separating a volatile component from non-volatile component by heating the mixture. So volatile component which is present in more amount like solvent, non-volatile component which is present in less amount like solute. If you take ink, in that water it is a solvent, and we are having some type of dye which is a solute. Here volatile component means which is not stable. Okay, it may convert a solid to liquid or liquid to gas. It is not stable. For example, ink is a mixture of dye and water. If some ink is heated in a dish, the water evaporates and the dye is left in the dish. Similarly, we can separate a mixture of salt and water or sugar and water by evaporation. Here you can see the picture clearly. We have a retort stand, Bunsen burner and a dish, wire gauge. What we have to do? We have to heat the mixture of dye and water. I mean to say ink. You can use other example also. Salt and water, sugar and water. When we heat this mixture of dye and water, I mean ink, water will be evaporated and dye it will be left on a china dish. It is a evaporation example. Decantation using separating funnel. You know what is meant by decantation. If you take mud water, if you won't disturb that water which is present in the beaker, then heavy particles settle down. That is known as sedimentation. If you take up of the water without disturbing that heavy particles, we can say that process is decantation. So here decantation using separating funnel. You can see this picture. This is known as separating funnel. Two immiscible liquids such as kerosene and water we can separate by using this method. This method is used for separating a mixture of immiscible liquids. Liquids separate into different layers depending on their density. Water density is high, it will be down. Kerosene density is low, it will be up. If you take a mixture of kerosene oil and water in a separating funnel, it forms separate layers of oil and water. The water can be separated by opening the stopcock. After the water flows out, the stopcock can be closed. In this manner, we can separate kerosene from the water. This is one of the method to separate two immiscible liquids. If you want to separate miscible liquids such as ethyl alcohol and water, acetone and water, we have to use fractional distillation method. This method won't work. So let us see that method also. One by one we will see. So now next method we are going to see sublimation. Sublimation. You know what is meant by sublimation. If a solid directly converted to the gas known as sublimation. Examples are ammonium chloride, dry carbon dioxide, dry ice, naphthalene, anthracene, camphor. These are the examples. This method is used to separate a mixture of sublimable component from a non-sublimable component by heating the mixture. Example, ammonium chloride and common salt. These two are salts white salts, very similar. If you want to separate them, this mixture, we have to heat it up. We have to take a funnel, we have to take that funnel reverse, and at the mouth of the funnel we have to close with cotton. You can see this picture clearly. So we have Bunsen burner, China dish, mixture of ammonium chloride and salt. Ammonium chloride and salt, both we have to mix properly. We need a funnel, we have to invert it, inverted funnel. Then what will happen when we heat it? Ammonium chloride, it will convert directly solid to gas. It will be deposited at the walls of the funnel. Ammonium chloride solidified we can get by the walls of the funnel. So here we can say ammonium chloride directly converted solid to gas. Sublimation. Okay, this is the example of sublimation. By this process, not only ammonium chloride salt, we can separate naphthalene, anthracene, camphor, dry carbon dioxide. These are all if it is there with other substance mixed together, by heating that we can separate them. This method is sublimation method. Chromatography. This method is used for separating colored components from liquid by using filter paper or blotting paper. So here filter paper, why means we have to use filter paper as a absorbent. You can use magnesium oxide or aluminate also. These are good absorbent. Okay, so with this filter paper or magnesium oxide, capillary action is taking place properly. It means generally water flows from higher surface area to lower surface area. But here what will happen? When water is touching the filter paper, it flows up reverse direction. This is known as capillary action. So let us see this example. Put a drop of ink near one end of strip of filter paper and dip the end of the paper in a test tube containing water or beaker. Ink is a mixture of two or more colored components. The component which is more soluble in water rises faster and gets separated. So here when we keep ink dot upon the filter paper, upon the beaker, by using one pencil and a white tape, we have to paste this filter paper upon the pencil. That pencil we have to keep upon the beaker and draw a one line. Upon that line you take one permanent ink mark or any ink mark. Make sure that this dot should not touch the water, but this filter paper, end of the filter paper should touch. When it is touching the water, water starts flowing down to up, which is known as capillary action. Because of the capillary action, whatever the components are there upon the dot, those also will move up. So moving components of the ink up is known as capillary action. In this manner we can separate the components of the ink. If you want to know flower extracted dye having how many components, you can use this method, chromatography method. This method we have studied in 7th class also. We have to take one chalk piece. Upon the chalk piece we have to make a mark, ink mark, and you have to touch that chalk piece end to the water. Then what will happen? This will flow up. When it is moving up, this will produce, creates different marks upon the chalk piece. This chromatography we have studied in the 7th class. Now we are going to see another method, distillation. Generally this method we are using in laboratory. Generally whenever we are performing the activities, we won't get any result, any chemical reaction. Problem is that water problem. If you are using tap water or ground water, any other water, we won't get any result. If we are doing the activity same with distilled water, we will get the result. So we need distilled water. So this process we are using in chemistry laboratory. Generally we are taking water in a round bottom flask. With the thermometer we are checking the temperature. By heating with Bunsen burner, so water will evaporate and it will be passed through the delivery tube which is having a condenser. So whatever the water converted liquid to the gas, it will be cooled with the condenser. Drop by drop we will convert into the water again in another vessel. So what will happen? Whatever the impurities are there in that round bottom flask, it will be there only pure water will be evaporated. In this manner we are getting this distilled water which is used in the chemistry laboratory. We know that when we buy one syrup for the small kids medicine, along with the medicine they are providing one small bottle, okay, that we have to mix with the medicine and we have to shake it, that is distilled water only. So let us see this method as per the experiment. So here this method is used for separating mixture of miscible liquids by boiling the mixture and cooling and condensing the vapors. For example, we can separate acetone and water. Okay, simple distillation. It is used for separating a mixture of two miscible liquids having sufficient difference in their boiling points. It means boiling point difference should be more than 25 kelvins. Then only we can use this method. If it is less than 25 kelvins, we have to use fractional distillation method. So here if a mixture of acetone and water is heated in a distillation apparatus, the stone which has a lower boiling point than water first boils and cools and condenses and separated from the water. So acetone and water we are heating. Acetone is having a lower boiling point compared to the water. So first acetone will be evaporated and along with the delivery tube it will be cooled and collected in another vessel. In this manner we can separate acetone from the water. Now fractional distillation method. In this fractional distillation method we can separate two miscible liquids which are having their boiling point difference less than 25 kelvins. Okay, let us see. Fractional distillation, it is used for separating a mixture of two or more miscible liquids which difference in boiling point is less than 25 K. The apparatus used for fractional distillation is similar to that used for simple distillation, except that fractionating column is used between the distillation flask and condenser. If you are not using fractional distillation column, that is a simple distillation. In this fractional distillation, we have to use special fractional distillation column as a apparatus. Okay. The fractionating column has glass beads which increases the surface for the vapors to cool and condense. Fractional distillation is used for separating the components of petroleum, separating the different gases from the air, etc. Here you can see the picture. So here I will take one example such as oxygen, nitrogen, argon. If you want to separate these gases, we have to use fractional distillation column. Not this experiment setup, we have to use another one, but boiling point difference should be less than 25 kelvins. Let us take one example. Oxygen, nitrogen, argon. These gases are having closer boiling points. If you want to separate them, we have to use fractional distillation column. So not this, we have to use separate one which is very different. So in that case what will happen? So here first nitrogen gas which is having minus 196 Kelvin boiling point, that will be separated out. Then argon minus 186 kelvins. Then at the end oxygen minus 183 kelvins. In this manner these three are having very close boiling points. If you want to separate them, we have to use fractional distillation column. We can separate nitrogen, argon, oxygen type of gases by using the fractional distillation method. Crystallization. Purification of solid by crystallization. Crystallization is the process of obtaining a pure solid in the form of crystals from its solution. Example, by crystallization we can obtain pure copper sulfate from its solution. What we have to do? We have to dissolve about 5 grams of copper sulfate in a minimum amount of water. Filter the solution to remove the impurities. Evaporate the solution in a China dish to get a saturated solution. Cover the solution with a filter paper and allow it to cool. Pure copper sulfate crystals are formed. So this is the method to get pure copper crystals by using the crystallization method. So here we have one more terminology, water of crystallization. You can take example of copper sulfate only. What is the meaning of water of crystallization? So here copper sulfate formula is CuSO4 5H2O. It means one formula unit of copper sulfate having 5 moles of water molecule. If this water molecule is not there, we can't get copper sulfate in blue color. So if you want to test, you take this solution in a test tube and heat it up. When water evaporates, copper sulfate we will get by the walls of the test tube in white color. It means copper sulfate, it is not in blue color. Okay, Now we add 2 drops of water, we will get copper sulfate in blue color. It means when we add water molecule to the copper sulfate, then only it will be in blue color. This is known as water of crystallization. Separation of component of air. Air is a mixture of gases. The components of air can be separated by fractional distillation. Air is compressed by increasing the pressure and cooled by decreasing the temperature to get liquid air. The liquid air is then allowed to warm up slowly in a fractional distillation column. Then the different components separated at different heights depending on their different boiling points. Already I said this example, air, if you compress and cool by increasing pressure and decreasing temperature, will get liquid air and allowed to warm up slowly in fractional distillation column. And when you pass them by the experimental setup, gases get separated at different heights. Already I said nitrogen we will get at this is minus our 196 Kelvin. Is argon will get minus pure 186 class Kelvin. 9 and oxygen will get 183 and Kelvins. CBSE also it will be useful to you. If you like my video, subscribe and like and share. Thank you.